Hello everybody, welcome to this video. In this video I'll be covering SLO number 4, where I solve trigonometric equations algebraically, determining all possible solutions and or solutions on a given interval. So for number 1 we have find all possible or exact solutions for equation cosine theta equals a half, where the interval is 0, is less than or greater than theta, and theta is less than 2 pi. So we start with cosine theta is equal to 1/2, in which you could use the unit circle and you could find that theta equals pi over 3 and 5 pi over 3. So to find all possible answers, you will add just 2 pi n being an integer that could be multiplied by whatever number. It's plus or minus in this case, as is seen here. The next one is you take the 5 pi over 3, again you plus or minus the 2 pi n. This gives you, it's like adding 360 or 2 pi to it to you to get the next interval. But in this interval where it ends at 2 pi, you only get 2 answers, but these will be all the possible answers. So the next question we have, find all possible and exact solutions for the equation sine theta equals a half. Just like the other one, 0 is less than or equal to theta and theta is less than 2 pi. It ends at 2 pi. So sine, we go again, sine theta equals a half using the unit circle, or just if you memorized it, you know that theta equals pi over 6 or 5 pi over 6. To find all possible answers, you would just add 2 pi n or subtract 2 pi n. And for the 5 pi over 6, you will add 2 pi n or minus 2 pi n. For the third problem, we have find all possible exact solutions for the equation 7 cosine theta minus 3 equals negative 10. So in this case, it will also be where 0 is less than or equal to theta and theta is less than 2 pi. So we're going to take the problem, the equation. We're going to move the 3 over, this canceling out, and then this will equal 7 cosine theta, which equals negative 7. And then you'll be dividing by the 7 in this case. You divide by the 7, leaving you negative 7 divided by 7 to equal negative 1. Cosine theta equals negative 1 only in one location, which again you could either divide by cosine here, giving you the arc cosine of negative 1. So again you're dividing, so this will cancel out, giving you theta equals negative cosine or arc tangent, not arc tangent, arc cosine of negative 1, which theta then equals pi. It's the only place that cosine is negative 1 in the restrictions given in this, whereas ends. In this case, you can also add 2 pi n or subtract 2 pi n here to be giving you all possible solutions to this problem. The equation, I guess you could say. So for the next one we have 4, which is find all possible exact solutions for the equation. Again, this looks difficult, but it really isn't. We have the same parameters to where 0 is less than or equal to theta and theta is less than 2 pi. So we take the problem, we move the 15 over, making this cancel out, and this equaling 16 is sine squared theta, which equals to 8 when you add these two together. And you divide by 16 from here. This will cancel out. And then you can reduce this by dividing by 8 in both sides. Well, not both sides, I guess denominator and numerator. So when you divide by 8, you will get 1 over 2. In which case you have sine square theta equals 1 over 2. You take the square root of sine from up here, which I did down here. Then you have equals plus or minus 1 over 2. The square root of 1 over 2. You got sine of theta equals plus or minus 1 over square root 2. Again, the square root 1 will just give me 1. And then this equals to plus or minus square root 2 over 2 when you move the 2 over. So in this case, theta will give me pi over 4, 3 pi over 4. You can find this by, using the unit circle, or you could divide by sine here, and then putting arc sine into this plus minus, and then plus minus square root 2 over 2. Giving you this will be for this one. And then the 5 pi and 7 pi over 4, that will be for that one. That's what that is. For the next one, we have 5, which is find all possible exact solutions for the equation of 138 sine squared theta plus 69 sine theta equals 0. So for 0, it's we have the same parameter here for theta. So we're going to be using, or we're going to be substituting sine theta for x. So in this case, it'd be like a quadratic. So we have 138x squared plus 69x squared. You set it equal to 0, and you got you could what's it called? You could take out an x from both since there. You got an x here as well as over there. So you could take out an x, giving you 138x plus 69 equals 0. Again, you can set this equal to 0. And then you have, when you solve them, well, you could go to move this one. Let's move the 69 over here. So then we have 138 equals negative 69. You divide by 138. And then again, you divide by 138. X equals negative 1/2. And then you substitute the sine theta for x. So sine theta equals 0. And then here, sine theta equals negative 1/2. In this case, you have 0, comma pi, where this happens. And then for this one, you have 7 pi over 6 and 11 pi over 6 for this one. So in this case, you have 4 solutions and for this square right here. For the next, we have 6, find all possible exact solutions for the equation 5 tangent theta plus 3 equals 14 plus 4 tangent theta. Again, same parameters for x. Well, I guess this would be theta, not x. So theta. So you got 5 tangent theta plus 3 equals 14. Again, you're going to move the 5 over. Well, you're going to distribute the 5 here and here, giving you 5 tangent theta plus 15. And equals, again, 14 plus that. You're going to subtract this negative 4 here and the 15. So you're moving stuff around. You move the 15 over, and you move the 4 around, canceling it out, giving you tangent theta equals negative 1. Because this would just give, this will subtract to just 1. So this is imaginary 1 goes right here. So theta equals 3 pi over 4. It's the only place where negative 1, oh, no, there's also 7 pi over 4. I was thinking about something else. So tangent theta equals negative 1 and 3 pi over 4 and 7 pi over 4. To find all exact possible solutions, you could add 2 pi n or subtract 2 pi n. And that's everything. Thank you for watching.